Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on numerical problems on phase controlled rectifier in the second module. So all are gate questions. So first problem is in the 2024, a single phase triac based AC voltage controller feeds a series RL load. The input AC supply is 230 volts 50 Hz. The value of R and L. R is the 10 ohms and L is the 18.37 millihenries. And now here the minimum triggering angle of triac to obtain the controlled output voltage is. So now here we need to calculate the alpha value. So now here what is the formula? Actually this alpha is always greater than theta. So now here frequency is given, that is 50 Hz, and R is given, that is 10 ohms, and L is 18.37 millihenries. And now here, so what is the formula for theta? So now here the minimum triggering angle, so that is the minimum triggering angle is theta equals to tan inverse omega L by R. So tan inverse XC XL by R. XL means omega L by R. So now here omega. So what do you mean by omega? Omega equals to 2 pi F. So now here omega L equals to 2 pi F L. So now by R, so this is R, this equals to tan inverse omega 2 pi F L by R. So now here we know the 2 pi, 2 into pi into, and R F value is 50 Hz, and now here L is 18.37 into millihenries 10 power minus 3 divided by resistance R is 10 ohms. So now if you calculate this one, so the value of theta is 29.989 degrees. So now here I minimum, so alpha minimum is around, this is almost 30 degrees, 29.9. So now second question, gate 2023, the single phase rectifier consists of 3 thyristors. So T1, T2, T3 and one diode, and here feeds power to a 10 amp current source, that is constant load, constant current load, and T1 and T3. So this T1 and T3 are triggered at 60 degrees. So T1 and T3 are triggered at 60 degrees, that is pi by 3. So T1 and T3 are triggered at 60 degrees, and T2 is triggered at 240 degrees. So it is up to 180 degrees pi, and next cycle, so T2 is fired. So this T2 is fired at 2 pi plus alpha means 240 degrees. So here the conduction in this duration pi to pi plus alpha, that is 240. So T1 and T3 semiconductor devices will conduct. After that a T2 switch will conduct at 240 degrees. Here alpha equals to 60. The rectifier alpha is positive, zero crossing of input voltage, and calculate the average output voltage. So now here, so from this waveform, this is your output waveform, this is your input waveform. Input voltage is always sine wave. Here we are getting the output voltage. We need to calculate this average value. So calculate the average value for this output waveform. So now here, if you see this waveform is given. So now here, in this case, so now here there is no negative output voltage because both are thyristor, but here there is a negative voltage. T1 and T2 and D1 switches will conduct. So now here if you see this one, so now here how we will calculate this one, average value, total time period divided by total time period. What is the time period here? Time taken to complete one cycle, that is 2 pi, T equals to 2 pi. So T equals to 2 pi, and area under the curve divided by total time period. How we will calculate this one? So it starts from alpha to pi, and next pi to pi plus alpha. So this value is 0. So no need to calculate. And next pi plus alpha to 2 pi plus alpha. Here you need to calculate up to this one. So that is minus Vm sin omega t. So now here, if you simplify this one, so the average output voltage equals to Vm by 2 pi 1 plus 3 cos alpha. So now here Vm equals to, what is the value of Vm? Vm equals to 100 and 2 pi, alpha equals to 60 degrees. Now here this output voltage equals to 39.79. Next problem. The circuit shown in the figure has reached steady state with thyristor T is off condition. So T3 is off condition means here T is less than 0. And now here assume that the latching and holding currents of the thyristor are 0. So IH holding current and IL values are 0. The thyristor is turned on at, means latching current means latching current and holding current. Holding current means when anode current is less than the holding current, the thyristor is in reverse bias from the forward conducting mode to forward blocking mode. But here this one is IL means anode current reaches from when it is greater than IA is greater than IL. So in this case the thyristor comes from forward blocking mode to the forward conduction mode. So now here these conditions, IL equals to 0 and IH equals to 0. So now here thyristor is turned on at T equals to 0 seconds. So duration in microseconds for which the thyristor would conduct before it turn off. So now here, so it was asked in 2023. Now here supply voltage is 100 volts, and now here this is the resistance, and now here this is the inductance, and this one is the capacitance equals to 1 microfarad, and this is the L equals to 4 microhenries. So now here we have two conditions, T is less than 0 and T is greater than 0. Two conditions before switching and after switching. So now here T is less than 0 and T is greater than 0. How it will works? So now here at steady state condition T is less than 0. So in this case capacitor is replaced by open circuit. So here T is less than 0 means capacitor is replaced by open circuit, and inductor is replaced by short circuit. So now this inductor is replaced by open circuit and capacitor is replaced by short circuit. Now calculate the open circuit voltage. This open circuit voltage equals to 100 volts and 100 volts, and short circuit current is 0. And now here when T is greater than 0, so inductor current and capacitor voltage when it is t is greater than 0 and inductor current. So now here IL equals to 0. And now here when t is greater than 0, how it will work? So now here current source in parallel with this current is 0. So now here current source in parallel with this one means this current is 0 means no need to cross. Now here when t is greater than 0 means here this inductor, this open circuit voltage is 100 volts and this parallel current source current is 0 and 4 microhertz and 1 microfarad, and this is the thyristor and 4 ohms resistor. So now here how you will calculate this 4 ohms current equals to this 100 by 4. So that 4 ohms current equals to 100 by 4. And next case here this IC, this capacitor current IC equals to this IP means here supply voltage into this C and this L. So into sine omega naught t. So 100 into square root of 1 microfarad by 4 microfarad into sine omega naught t. So that value equals to, this is 1 by 2. And now here it is a 50 sine omega naught t. So now this is 50 omega naught t means here this is IC only. So from this here IT equals to, so now here IT equals to this 4 ohms current plus and this IC current. So now here if you apply here, so this 4 ohms current plus this 4 ohms current plus IC current. So that current IT current equals to, in this, so this current equals to this IC current plus, so this IC current plus this IT current. So now here these two currents. So now here 25 plus sine 50 sine omega naught t. So that equals to omega naught t equals to 210 degrees into pi by 180. So now t equals to, what is the formula actually? So now here square root of LC. L value we know very well. So now here L is 4 into 10 power minus 6, and now here this is only 1. C value is 1 microfarad. So now here this is 7 pi by 6. So pi by 6, and that is the time is here 7.33 microseconds. Now fourth question. For the ideal AC to DC rectifier. For the ideal AC to DC rectifier, and now here as shown in the figure, the load current magnitude is IDC. So now here that is 15 amperes. IDC, that is 15 amperes, that equals to 15 amperes, and is ripple free. So ripple free means there are no ripples, and thyristors are fired with delay angle alpha equals to 45 degrees. The amplitude of fundamental component of source current in the amperes is, so now here it was asked in 2022. So now here, so now what is the question here? Amplitude of fundamental component of source current. So now if you write the source current equation, so now here this is Fourier series expansion for this output voltage, sigma n equals to 135 infinity 4 into this I naught divided by n pi. So now here cos n alpha by 2 sin n sin omega t plus phi n. So now here fundamental component current equals to, this is Fourier series expansion for this current, and fundamental component current means here n equals to 1. So here n equals to 1 means here, so this n is 1 and this n is 1 and this n is 1. So now here is1 equals to this one equals to n omega t and cos alpha by 2 alpha value is 45 is given. So this current equals to 17.64 amperes. Next, fifth question. The voltage at input of AC to DC rectifier is given by V of t 230 root 2 sin omega t and omega equals to 2 pi of radians per second. So the input current drawn by the rectifier is here. So 10 I of t equals to 10 sin omega t minus pi by 3 plus 4 sin omega t minus pi by 6 and 3 sin omega t 5 omega t plus pi by 6. So calculate the input power factor. So it was asked in 2022 GATE. Now here, so first fundamental component n equals to 1, n equals to 3 and n equals to 5. So 5 1, 5 3 and 5 4. Now here Vm1, Vm2, Vm3, sorry, Vm5. So now here input power factor formula. What is the formula? That equals to power factor equals to G into fundamental displacement factor. So G equals to fundamental component current divided by this ISR, total RMS current. So now here RMS value, how we will calculate for the entire equation in this. So now here this is a maximum value by root 2, maximum value by root 2, maximum value by root 2, this one. And now here fundamental means this is only IS1, that equals to 10 by root 2, and now here for this total is 10 by under root, this 10 by root 2 whole square, and now here this 4 by root 2 whole square, and next this 3 by root 2 whole square. So this is your G value only, fundamental displacement factor. So now here how we will calculate this cos 5 pi by 3. So this is a pi by 3 fundamental. So that is pi by 3 means that equals to 0.5, that equals 1 by 2. Here we got 0.894. Input power factor equals to G into fundamental displacement factor. So that equals to G value is given 0.894 into 1 by 2, that equals to 0.447. This much value. Now here, sixth question. A single phase full bridge diode rectifier feeds a resistive load of 50 ohms from 200 volts 50 Hz single phase AC supply. So now here the diodes are ideal, then calculate the active power. So drawn by the load, that is in watts. So now if you see the formula, so average RMS value of output voltage equals to, so the maximum value divided by Vm by this Vm by root 2. So now here what about this one? So first here active power formula equals to V0 RMS square by R. So here we need the V0 RMS, output RMS voltage. Here output RMS voltage equals Vm by root 2. So that equals to Vm equals to, how we will calculate? So the given voltage is 200. So Vm equals to 200 into root 2 by root 2. This is, and here your output RMS value is for single phase off bridge rectifier is diode rectifier is 200 volts. And now here what about power factor? 200 square by 50. So this is 200. So this 200 square by 50. This is supply give voltage. This is the RMS output voltage. This voltage you need to take. So that is 250 by R value is given. So that is the 50 ohms. Total active power drawn by the load is 800 watts in the watts only. Now here, seventh question. This is very simple problem in the 2021 gate question, and waveform shown in the solid line. So this is a waveform shown in the solid line is obtained by clipping full wave rectifier sinusoidal. So as shown in the dashed line, so the ratio of RMS value of full wave rectified waveform to RMS value of clipped waveform. So that you need to calculate. How to solve this problem? So now here this is trapezoidal type, but this is up to this sine wave. This is the straight line parallel to the x-axis, and this is a sine wave. So this area and this area is same. So now if you calculate this area and then multiply with 2, so both. So now here next case is this one, 0 to pi. So now here, so Vm sin omega t. So output voltage equals to from 0 to t is omega t is 0 to pi by 4. And now here this value is 0.707 Vm. So that is pi by 4 to omega 2 to 3 pi by 4. So now here this is Vm sin omega t. So that equals to 3 pi by 4 omega t is a pi. This much. So now here if you calculate this much, no problem, multiply with 2. So now here, so the RMS output voltage equals to 0.707. So now here the clipped waveform here multiplied with 2. So now here multiplied with means if you calculate this one, so only 1 you take and multiplied with 2. So now here 0 to pi by 4 Vm sin omega t whole square. And now here this is straight line parallel to the x-axis 0.707 Vm square d omega t. So pi by 4 to 3 pi. So otherwise remove this to 1 and you can add another one 0 to 3 pi by 4 to pi. So both are same, but you will get the same value. So now if you simplify this one, how you will calculate this one? So now this is Vm square by 2 into pi by 2. This is 1 by root 2. 0.707 means that is 1 by root 2. 1 by root 2. So now here sin square omega t means 1 minus cos omega t. So cos 2 omega t equals to 2 sin square 1 minus sin square 1 minus 2 sin square. So now here, so 1 minus cos 2 omega t by 2. So that is the sin square t equals to. So now if you simplify this one, so now here if you integrate it, so that is 1 by pi, everything is under root Vm square, 2 gets cancelled here. So pi by 4 minus 1 by 2 sin pi by 2 Vm square by 4 into pi. So now the simplified value is here 0.5838 Vm. So now here we need the RMS value of clipped waveform. So this is a clipped waveform. So now here we need to calculate the ratio of. So now this RMS value of full wave rectified voltage, that is a 0.707 Vm, to RMS value of clipped waveform. So that is a 0.05838. So now the ratio is 1.21. Eighth question. In the circuit shown, the input voltage Vi is sinusoidal voltage. So sine waveform, that is AC. Having RMS value of 230 volts, 20%. So the worst case peak inverse voltage seen across any diode is, in the volts it was asked in 2021. Now here, so the worst case is 230 into 20 volts, 20% means that is 230 plus, in this 20% means 230 into 20 by 100. So now here peak value equals to, so this peak value equals to, so maximum RMS value equals to, Vrms equals to maximum value by root 2. So this maximum value, peak value equals to root 2 into RMS. RMS value is given. So this is the RMS value into root 2. So now here your output voltage peak value of this diode is 390.32 volts. Ninth question. A single phase full bridge fully controlled rectifier feeds a load having 10 ohms resistor in series with large inductance. Now here the rectifier is fed from 230 volts, 50 Hz. So now here that is sinusoidal sine wave source through cables having negligible internal resistance and total pure inducting, I think total inductance is 2.28 millihenries. If the resistors are triggered at an angle of 45 degrees, the commutation overlap angle in degrees, so that is 20. It was asked in 2020. So now here how to calculate this first. This is important, commutation angle, so that is alpha. You need to calculate, this is alpha. So triggering angle, this is a mu. Mu is a overlap angle, commutation overlap angle. So now what is the formula? So this mu you need to calculate. Delta Vd is equals to Vm by pi cos alpha minus cos alpha plus mu. We know very well this formula. So Vd equals to 4 into F into Ls into I naught. So F is given and L is given 2.28 millihenries, F is 50 Hz, and I naught you need to calculate, and V naught equals to, what is the formula again? So 2 Vm by pi cos alpha minus 4F Ls I naught. So first calculate this from this I naught. I naught you need to calculate. I naught equals to 2 Vm by pi cos alpha minus 4 F into Ls into I naught. So now here first calculate from this equation. I naught you need to calculate. So now here is a I naught and here is a I naught. So 2 Vm is 230 volts into root 2 by pi cos 45 minus 4 into F into L. So that is into 10. So from this you calculate the I naught equals to 14.0036 amperes. So now substitute this I naught in this. So now here this equals to, what is the formula? 4 into F into Ls into I naught. Substitute this I naught in this. L value is this much and F is 50H. And now here Vd naught equals to 230 into root 2 by pi cos 45 minus cos 45 plus mu. So from this calculate the mu value. So that is a commutation overlap angle 4.80. 10th question. Consider the diode circuit as shown in the below. So the diode D obeys the circuit voltage current characteristics. So now here that equals to I of s exponential. So the e power Vd n into Vt minus 1. So we know very well this one. So when n is greater than 1 and V of t is greater than 0, Vd is the voltage across the diode. And Id is the current through it. So this Id is the current flowing through it and the circuit is biased so that the voltage is V is greater than 0 and I is less than 0. If you had to design the circuit to transfer maximum power from the source current to resistive load, that at output and R1 R2 will be maximum or minimum. So this is important. So now here Vd equals to this so here this R1 is low and R2 is high. So now Vd equals to V by R2 by R1 plus R2. R2 is large means here Vd becomes very low. So this is the like voltage division rule. So when R2 is large and Vd becomes large, and when R2 is less, Vd becomes less. So this is maximum power when R1 is small and R2 is large. This is again voltage control rectifier, and now here thyristor T1 is triggered at alpha and T2 is triggered at 180 degrees plus alpha. This one. In each off cycle of sinusoidal input voltage, assume the both SCRs, thyristors, to be ideal and to control the load power over the range from 0 to 2 kilowatts. So the minimum range of variation of alpha value you need to calculate, that alpha range you need to calculate these values. So how you will calculate first alpha value? So we know very well this formula, RMS output voltage equals to under root, that means 1 by 2 under root Vm by root 2 pi minus alpha 1 by 2 sine 2 alpha. Alpha range we need to calculate. So this is supply voltage is given. Supply voltage is given and this is current waveform. Current lags voltage by 60 degrees. And here alpha you need to calculate. So now here T1 will trigger at this one alpha and T2 will trigger at 5 plus alpha. So this is T2. What is the value of, so after getting this power value of RMS value, so what is the formula? V naught RMS square by R. So this impedance Z, so that is Z equals to 10. So now here R V naught RMS square unit to calculate. R value is 5 ohms. R value is here 5 5 5 volt 5 ohms, and now here alpha equals to 0, and now here if you substitute alpha equals to 0, this is completely 0, and this is pi gets cancelled, and Vm by root 2, that is 200. P naught equals 200 by 20, that is 2 kilowatts. When alpha equals to 120, so the current distinguishes P naught equals to 0. So now here alpha value from 0 to 120 degrees. So from 0 to somehow here is only a single phase full bridge diode rectifier fed from a 230 volts 50 Hz sinusoidal source supplies a series combination of finite resistance and a very large inductance L and two most dominant frequency component in the source inverter. So we have seen already this Fourier series expansion for this output current, so that equals to, so 4 sigma n equals to 1 3 5 infinity 4 I naught n pi sin nd. So now here this d is the pulse width, and now here sin of n pi by 2 sin of n omega t plus phi. So here the pulse width equals to 2d equals to pi. Pi has now d equals to pi by 2. So this is a pi and this is a pi by 2. So now if you substitute d equals to pi by 2, so now here n pi by 2, and now here this equation, this simplification is here sin square n pi by 2 sin of n omega t plus phi. Sigma n equals to 135 infinity. So now here I source is always not equals to 0. So the most dominant frequency component will be 3f, and f equals to 50. So now here 3 means 3 into 50 means that is 150. 2 most dominant means first 2. 3 most means 5 into 50, that is 250. A single phase fully controlled thyristor converter is to obtain average output voltage 180 degrees volts with 10 ampere constant current source to feed a DC load. It is fed from 180 single phase AC supply of 230 volts 50 Hz. Now neglect the source impedance. The power factor is power factor of AC means. So it was asked in 2019. So we know very well this formula. So output power equals to V naught into I naught. This source RMS and voltage into source RMS current into cos phi. Here single phase fully controlled converter. So I naught equals to ISR. So source RMS, this 2R gets cancelled. So now here cos phi equals to V naught by V source RMS voltage. So now here how you will calculate, this is the source RMS voltage, that is 230, and now here this average voltage output voltage is 180, so that equals to 0.78. So this is very simple question. So it was asked in 2019. A fully controlled 3-phase bridge rectifier is working from 415 volts 50 Hz AC supply. It is supplying constant current of 100 amperes at 400 volts to DC load. Assume large inductive smoothing and neglect overlap. And the RMS value of AC line current in ampere is. This is the formula. So IS RMS equals to I naught into square root of 2 by 3. So this is obtained from the waveform. So now here 100 amperes was given. So your output current RMS value of AC line current, so that is 81.65 amperes. 15th question. A 6 pulse thyristor bridge rectifier is connected to a balanced 3-phase 50 Hz AC source. Assuming that DC output current of rectifier is constant. The lowest harmonic component in the AC output voltage is, so that is you need to calculate, it was asked in 2019. So 6 pulse converter harmonic present in the AC circuit is here 6K plus 1. Here your lowest order harmonic is 5 in this. Now here the lowest order frequency is here 5 into 50. In the 6 pulse the lowest order harmonic is 5. A phase controlled single phase rectifier supplied by a AC source DC power to a RLE load as shown in the figure. The rectifier output voltage has average value is given by, so this is important, V0 equals to Vm by 2 pi 3 cos alpha. So now here Vm is given 85 volts. Alpha value is the firing angle. If the power delivered to the lossless battery is 600 watts. So now here EB into I0. EB value is given, so that is 80. EB value is given, so that is the battery voltage into this current is the power, that is the 1600 watts. So now here V0 equals to Vm by 2 pi 3 plus cos alpha. I0 equals to, how we will calculate this power by this battery voltage, that equals to 20 amperes. So now if you apply KVL in this loop, V0 equals to EB plus I0 into RA. So now we have all the formulas from this, you can calculate the alpha. So V0 is this much, in this alpha you need to calculate, EB is 80 this much, and next I0 is 20 amperes. So now here this is 2. Now here in this case alpha equals to 90 degrees. The waveform of current drawn by semi-converter from a sinusoidal AC voltage source is shown in the figure. I0 equals to 20 amperes. RMS value of fundamental component of current. So know very well this one. So we have seen 4 pi. So 4 pi I0, 4 I0 by n pi cos n alpha by 2 sin n omega t alpha by 2 sigma n equals to 135 infinity. This is ISN is equals to. So now here this is fundamental component of source current. So now source RMS equals to by root 2. So 4 I naught by a pi root 2 equals to, so this is I naught equals to 20 amps is given, and alpha value is given, that is 30. So now here 2 root 2 by pi 20 into cos 30 by 2 is the IS1 fundamental component of source RMS current is 17.39 amperes. A single phase fully controlled rectifier is supplying a load with anti-parallel diode as shown in the, so a load with anti-parallel diode as shown in the figure. All switches are diodes here, D1, D2, D3 and D4. Here all switches and diodes are ideal. So which one of the following is true? Instantaneous load voltage and load current. So here V0 and I0 are instantaneous load voltages and load current. Here both are positive. Option C is correct. So V0 is greater than 0 and I0 is greater than 0. So here this freewheeling diodes makes the output voltage is always positive. Output voltage and output current is continuous. Now here in the circuit shown in the figure, so the diode used is ideal. So this is the ideal diode. The input power factor is, you need to calculate. So it was asked in the 2017. So now here this is the case. So input power factor equals to, this type of problem we have already discussed in the previous the second problem, I think. So input power factor is equals to V0 RMS by source RMS, that equals Vm by 2 by Vm by root 2. So this one, so that equals 1 by root 2, that equals to 0.707. No units for power factor. Next, the figure shown below shows here the circuit diagram of controlled rectifier supplied from 230 volts, 50 Hz, and a single phase voltage source and 10 this is single phase voltage source, and here is a one ideal transformer 10 by 1. So number of turns in the primary is greater than number of turns in the secondary. Assume all the devices are ideal. The firing angle of thyristor T1 and T2 are 90 and 270 respectively. So now here calculate the RMS value of current flowing through D3. This current. So now this D3 current is 0. Diode current is 0 because FD will not conduct for resistive load. So this is purely resistive load. So in this case, so sometimes, so here because of this inductive load, R load, RL load, pure inductive load, only we will use this feedback diode will freewheeling diode will conduct. So here there is no need of this freewheeling diode in case of pure resistive case. So in case of pure resistive case, it is always positive output voltage. So now here, so the diode current, ID3 RMS is equals to 0. So because the freewheeling diode will not conduct for resistive load. So now here we have total 20 question we have solved from 2017 to 2024. So all these questions are gate gate questions, latest day gate questions. I hope all these problems are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.